Just put in the chat.
Okay. I will never get to all of the chats and everything else, particularly with, oh God, there's still people coming. Okay. All right. Okay, it's recording. Good. Okay, so welcome again. Thank you very much for being so punctual, everybody. And also thank you very much for your bravery in actually attempting all the chemistry work that has been put before you this week. I know it's daunting, but yeah, yes, I can. Sorry, I just have to put the tutorial doc up again. That's okay. I don't mind. It's fine. It's just when technology is never quite as advanced as you want it to be. Like it really should have just be there and that should be the way it works, but that's not the way it works. There it is again. Okay. What I wanted to do before I started throwing things at you, welcome Maddie, no worries, is, yeah, I know I wanted to put it on Interact too, but I've been told not to. For the moment. And the reason for that is apparently to encourage people to come to tutorials and not just download documents. The reason Tori can't open the worksheet, so it should have a little indicator on the bottom of the Word image to click to open. So
yeah, I tried that, but it's just not letting me open it at all.
That's where my tech knowledge tends to fall down. Has anyone got a walkthrough for Tori or a workaround?
Like I even saved it to my laptop and a USB and it just won't let me open it.
Okay. Worst comes to worst, Tori, I'll take your name down. Oh, thank you, Samantha. I was about to say I'll do the same thing tomorrow morning.
Oh, thank you.
That's lovely. Thank you, guys. Appreciate it. Yeah, before I began, I wanted to give you an anecdotal story, which is a bit of a tautology, but anyway, about me and chemistry in my early years. So in my, I think it was first year, they threw chemistry at me, and I failed it dismally. And this was a whole subject of chemistry, not just a topic within a subject like you guys have got, but a whole subject of chemistry. It was foreign to me completely, and I found it extremely difficult. So the takeaway from that is that I didn't completely ruin my life. Yes, I had to sit the damn thing again, but the second time I sat it, I was really determined that it wasn't going to beat me this time, and I managed to scrape a credit, which I was really proud of. And then later on, when we did organic chemistry, which is actually what you guys are doing at the moment, all of a sudden it started to make sense because things were actually related to body systems. When it was just that blank, hypothetical, theoretical chemistry, really, really hard. When it's associated with body systems, it is a little bit easier. And again, a bit like last week, I'm kind of hoping that once you see the level for this week, that you will be a little bit easier about the amount of content you've got to actually remember. So having said that, I will admit this person and we will get going. Okay. All righty. All right, chemistry, all very scary. Okay, I don't want you to worry about chemistry. That's first things first. The reason I even told you the anecdotal story in the first place. The second that you know this, guys, about human psychology, the second you tell yourself it's hard, the second you tell yourself you can't do it, it's a fait accompli. Right? You are literally shooting yourself in the foot for no reason. There is nothing in here that you cannot conquer. I'm confident of that. All right. And even if you get to the point where there is some of this that you absolutely think you'll never get, I guarantee you will. All right. It may be a sort of slow burn, and it may be a matter of just passing this particular point at this point. But as of next year, the year after, and what have you, it'll start to percolate, it'll start to become part of your knowledge base. If you really give it a good go, don't give up, don't let it beat you. Okay, so first things first, unlike last week, I am not going to answer your multiple choice questions for you. I'm going to give you a couple of minutes just to go through and see how you go with these first multiple choice questions, okay? So if you want to all get onto that, have a think, take it slow, make sure your brain's working well, but gently.
Are these questions going to be on here on the worksheet? Because I can't access the worksheet either. Yeah,
Okay, well, all right, well, just give it a couple of minutes and let those that can access the worksheet. Lara, did you want to send somebody your email in the chat so that they can get it to you?
Yes, please.
Yeah. So if you just pop your email in the chat, can someone who was sent through to Tori before also send to Lara?
Where is the worksheet? Is it on?
It's in the chat box, which I can't, hang on. Which I can't actually access while I'm sharing. Hang on, I'll try again. Let's see.
I've got it.
All right, someone's got it, yay. I'm gonna put it up there one more time and then I'm going to curse Zoom and the document both. Okay, there it is. All right. So we will give you a couple of minutes to have a look at the first 5, the multiple choice. This is the easy bit. That mightn't be comforting. And have a go. And then, of course, I will talk you through the answers. Okay?
Yeah, I got it. Thank you.
Yay! Good.
Did you need to turn the recording off for this or?
No.
No? Okay,
no.
cool.
Thank you, Isaac. But no, the answer is if people can't make it and they come across this bit, they're just going to have to use the fast forward button. Can't be technologically perfect. I haven't got the equipment nor the software for these things. I'd like to. Okay, can you guys give me a thumbs up or something along those lines when you're done, so I know I can jump with the majority? Or just yell at me. You can do that too. Thank you, Paige. Someone else is coming in. What's the bet? They say, where's the document? Maybe I'll just take care of that while you're working and put it up again. This will be 11 times now.
Did you want us to go through the whole tutorial or just the?
No, just the MCQs, mate.
Yeah.
Yeah, no, I think we will talk through the rest of that. I'm not going to make you just answer. It's not an exam. That'd be too stressful. No, just the MCQs. We'll do it section by section so that it's not too much for you. Okay, don't forget to let me know when you're done because we do only have the hour. So sorry to push you forward, but thanks, Ella.
Oh.
Thanks, Corey. And remembering what we spoke of last week in this particular area is that just in terms of the timing, multiple choice questions need to take as little time as you possibly can. So the level of knowledge that's in those, you want to be able to smack them out in under a minute each, just in terms of the timing of what's going on, okay? If you spend too long on them, you tend to run out of time, and that's a big problem. Yep. And also trust your gut a bit. Thanks, Lara. You probably have retained more than you think. They say, no, we haven't. Kath, rubbish. You have, promise. Just pure neurological science, you have, promise. You'll be having a random conversation one day and you'll come up with something chemistry related and you'll go, Invasion of the Body Snatchers, who is this person? Okay. All right. I think it might be time to jump to finding out how we're going. Is everyone close to finished? There's only 5. All right. I'm going to jump. Okay. All righty. Our nucleus has protons and neutrons. Who had D? Anybody?
I almost had D.
Almost, yep. And then you went, oh, no, wait, the electrons are on the outside.
That's
Yeah.
right.
Good, good. Yes, the nucleus has protons and neutrons. The outside energy rings have the electrons for all of our bonding and sharing. It's so very sweet and everybody gets together and makes molecules. It's lovely. Okay. B, or 2, sorry, would be the nucleotide chains of DNA specifically are held together by polar covalent bonds. Okay. The chains. Now, it is true that there are hydrogen bonds in DNA as well, but the actual chains of DNA are held together by polar covalent bonds.
I actually answered hydrogen bonds.
Yeah, but you're not 100% wrong. It's just one of those really annoying things where it's not the perfect right answer.
Okay.
Yeah, yeah. So if I were marking that, I would give it a half mark because
Okay.
you're not incorrect. The trouble is that most of the multiple choices are not marked by humans. Most of them are auto marked. So there's one correct answer, and that's that. However, feel happy that you're not completely wrong. You weren't
Okay.
off. You weren't
I
off
feel-
completely.
I
Is
feel
it
very
the-
confident that there's a lot of people coming in the chat saying they did the same.
They do the same.
Is it the hydrogen bonds that creates the coil shape and
Indeed.
the covalent bonds hold the molecule? Okay.
Indeed. Yep. Whenever you're thinking about molecules in particular, it should always be going there between covalent, between non-polar and polar covalent. So if it's a molecular bond, most of the time it'll be covalent. In fact, as far as you guys are concerned, it will be all the time. Yep. When you get to the idea of polar or non-polar, non-polar covalent bonds are very, very rare in the human body. So you can pretty much chuck that one and just go, it'll be polar. There will be a positive and there will be a negative. Yeah, Lara, did you have a question?
Is it because is it polar covalent bonds, are they stronger than hydrogen? Is that why they?
Yes.
Okay, cool. All right.
Yeah, the covalent bond is one of the strongest bonds. The hydrogen bond is actually fairly weak, although very common.
Yeah.
So there's lots and lots and lots of them. It's a little bit like when I think of a whole bunch of spider webs can hold a really, really heavy insect, but they're still not as strong individually as like rope. Yeah, does that make sense?
Yeah,
So think of hydrogen bonds as
Yeah,
spider
they're
webs.
strong. Yeah.
Yeah, and your covalent bonds, think of them as shipping rope. They're not letting go. Once those electrons are shared and you've got that polarity going on, so positive and negative attracting each other, they don't stop doing that.
Yeah.
It's quite extraordinary. You have to do something pretty big to get rid of those bonds, like cook an egg and denature the proteins. But anyway, we will get to that. Okay, that's 1 and 2. Let's move on to acidity. Which of the following, now this is a basic one where you have to know your pH scale and understand that 1 is most acidic and 10 is least acidic. So you could just go with numbers, yeah? Or you could go with instinct. You might get it right. A lot of people would say lemon juice though if they did that, but then hopefully they'd look at the numbers and get a hint. You go, well, hang on, but if lemon juice is pH 2 and stomach secretions are pH 1, no. What's the name of when they say stomach secretions that are acidic? What are they talking about? High.
Oh, high acidity. Sorry. Yeah.
Yep, that's right. So what is the name of the acid?
Is it bile?
Nearly hydrochloric acid. All right, so in your stomach, we have hydrochloric acid. We're really gross, actually, when you peel off the skin. It's all pretty gross in there. But particularly good, hydrochloric acid, in fact, all acids, are particularly good at denaturing one of our most important nutrients, which would be protein. Okay, so this is, acid. This is what you do to fish, right? If you cover it in lemon juice, is this a good thing when you're cooking? Right, denatures the proteins, actually makes it more tender. Yeah, another way you can tenderize meat is by bashing the crap out of it. That also denatures proteins, quite good. But acidity will denature proteins beautifully. So if you ever want to tenderize anything, the answer is acid. Okay, I'm hoping the next one was really easy because adult humans, right? Because we all, it's diet culture. We surely should have come across this. Glycogen, you might go, oh, not sure. Glucose, we know that they're carbs, right? And we also know that carbs are bad. Everybody, I'm joking. Obviously, they're not. They're delicious and wonderful. But, societally speaking, carbs are very bad. You can't have a carb or you will die of fatness. That's the way it's going to go. Okay?
Too late for me.
Yeah, too late. I know. Just my personal advice, guys, is that freshly baked bread is one of the best things in the universe. Don't deny yourself just because somebody wants you to be skinny. It's ridiculous, okay? And I'm certainly not. I'm very well covered. I've got a skinny face, but if you could see the rest of it, you'd go, oh, it's just fatter than I thought. That's okay. I intend to stay that way. Okay, so glycogen and glucose. What is the difference? Spot quiz. I hate it when she does that. What is the difference between glycogen and glucose? Any brave souls?
Glucose is when it's free flowing in blood, right? And glycogen's when it's stored.
Correct. Glycogen is the stored form of glucose in your muscles. Yep. Very, very handy if you go for a run, or like me, if you don't go for a run, it's really handy just to turn into fat later. So that's a good thing too. Okay, now the next one, this is, annoying and going to be in one of your exams, I promise. Okay, the structural level of proteins, they always ask this. So no primary, secondary, tertiary, quaternary structures. Alpha helix should be a big red flag. No, that's got nothing to do with anything. That's got to do with DNA, right? We're talking about proteins. So you do need to know that it's the tertiary structure. So primary structure of proteins would be just the amino acid chains. Secondary structure is when those chains actually start to fold and you get these beta sheets. Sorry, start to fold and you get your original foldings. After that, they join together and become sheets. It's a little bit like weaving. You're going to take a tiny little molecule and then you've got to turn it into a bigger molecule before it can bend in tertiary. Once it's bent, then quaternary is when you get a number of proteins coming in together to form a bigger structure. And I do have a picture of that too.
Talking about all that chemistry.
I am talking about all that chemistry. That's what they hired me to do. Dude. Okay. So have a look at this, guys. All right. Have a look at these structures and make sure that you can talk about them. Generally, I find they don't tend to ask you about the primary structure. They assume that you know that that's chains of amino acids. They will probably ask you about secondary, tertiary, or quaternary. Okay, so primary, it's just that. With secondary, you've got that hydrogen bonding between the groups and they start to coil. Then you get the overall folding into the 3D shape. Then you get different subunits coming in to create a complete structure. Like, for instance, anyone, if you look at that picture down there, does anyone know what that structure looks a bit like as a protein? You've probably seen it. It looks like hemoglobin. Okay, so hemoglobin is a quaternary, just hint by the way, this turns up a lot. Hemoglobin is a very good example of a quaternary protein structure. If you were asked to give an example, for instance, just saying. Okay, and you've got a bunch of different things going on in there, as you can see, guys. You've got hydrogen bonding specifically going on in your secondary structures. When you get into your polypeptide chain goes into a 3D shape, you have a number of different forces going on, both hydrophobic and hydrophilic attractions, as well as sulfur and water. And when you get that massive subunit going on and you're turning it into, say, hemoglobin, largely, weirdly enough, the stronger bonds actually happen earlier on. These ones are actually mostly held together by hydrogen bonds and something called Van der Waals forces. I used to say that me and my husband were attracted by Van der Waals forces because they were quite weak and easily broken. Just so you remember. Okay, all righty. How do we, out of 5, how do we go? Give me a thumbs up or a yell out if you got 5. Okay. Nice one. 4. Three. Good. 2. Good. 1. And you don't even have to admit to none. That's okay. That's a bit mean. Okay. You don't take this as a judgment on your personality or your ability. Okay. This is, again, this is why we do the tutorials. Remember what I said last week, that these tutorials are very closely aligned with your tests. So what you need to do is take those questions and look at them as blueprints and say, okay, you know what I need to do? I need to make sure I at least know those questions back to front. And obviously, if I don't know them, then these are good focus areas for me to go back into and have a look again at those sections, either in my textbooks or in the lectures. Or look, if none of that made sense, if the lecture was in Swahili and the textbook is gobbledygook, look up Khan Academy and see if they can explain it to you. Look up, just Google and then look for images and see if there's an image that makes more sense to you. Okay, but basically just be self-aware of that's a weakness. Tick, I need to go back in and get that. Okay, and you've got the rest of the week to do it. So don't let things pass you by. Don't go, I'm just crap at chemistry. You're not. You just need to do more work at it. Trust me, I was crap at chemistry. You just do more work at it and eventually you become less crap at chemistry. That's the way it works. Okay. Oh, look, I've just answered it for you. Bugger, I'm going to take back. Ah. Now that I've given you the answer, and if you're a quick reader, you got it. You need to try the next question. Okay, so listing the main kinds of chemical bonds. We've already talked about covalent, so you know that's one of them.
Hydrogen.
Yep.
Ionic.
On it. Good. Don't forget, this is open book too. You've got time. What are the major kinds of bonds? And what did it say? Does it say list? Yeah. So let's jump there because I've already done it. I've already stuffed it. The 3 main types of chemical types: ionic bonds, covalent bonds, and metallic bonds.
Hey, Catherine, in a test, see how in what you're showing now, it says list them and then kind of explains them. We would just list them, right? We wouldn't go.
Oh, I'm so glad you said that because that was my next question. What is wrong with the way I've answered this question? Go you. Go you. Yeah, a list is literally a list. So you should literally just write ionic bonds, covalent bonds, and metallic bonds. It doesn't say explain. It doesn't say define. It doesn't say anything like that. So it literally would just be the list. Very good. So well picked. Just you deserve a glass of wine for that. That's really good. That's excellent. Okay. No, I actually put the information there more for the sake of the tutorial. Yes, Steph.
Hey, did you just say metallic bonds?
Yeah, they're the three different main kinds of bonds.
Okay, I hadn't heard that term yet.
Yes. Okay. Have a look back through your notes, but they are your three different kinds of bonds. Mainly because we do actually have a lot of metals in us. And they have to be held together by something. But even if you only got two, they're like the ionic and the covalent. But we also have metallic as well.
Yeah, I got it as hydrogen as well.
I've got it as hydrogen too. I thought it was
hydrogen as well.
I got it as
hydrogen, right?
Yep.
Right.
I'd give that. As an exam marker, I would say if you got either hydrogen or metallic, they're both correct. In fact, there's more hydrogen bonds in the human body than there are metallic. So, you know, in terms of just amount, you're right, absolutely right. And I'd give that a full mark, as would everyone that's marking the exam. So good, but you don't need to describe them. I put the descriptions in there to make sure that we remembered what they were. Okay, but you don't need to put descriptions into a list, obviously, because you guys all listened to last week. Yay, good. All right, I'm going to move people up there. Good, let's move. Answering the next one, which is the denaturation of protein. I really should have put these somewhere where I didn't actually have to look at the next slide. Okay, so have a go at answering denaturation of protein. What happens? Right? In your own words. And I'm actually going to ask you. Yes, Steph.
I was just going to say my answer.
Oh, she's ready. Go. Absolutely.
Okay. Denaturation, is that how you say it?
Yeah, that's fine. Yeah.
Is when a protein's three-dimensional structure is destroyed and therefore cannot perform its function.
Like textbook. Perfect. Absolutely. Write that in your exam, okay? Exactly that. Yep, beautiful. Lara.
Could we, I don't know if I'm linking this right or wrong, so I could be completely off mark here.
That's okay.
Is it basically when it breaks the positive and negative connection that you said earlier? Is that correct?
That is exactly right. Yeah, there's many different ways of describing it, but what Steph said is what I would be concentrating on the most, which is that the biggest point of denaturation, apart from the fact that, like at this level, what we would like you to know is that bonds are broken irretrievably. Yep. So once those bonds are gone, they're gone. And once those bonds are gone, we go back beyond our tertiary stage. We're going back into the secondary and the primary stage. And you literally have all of those coils and beta sheets and what have you just unfolding. So it becomes a great big spaghetti mess of uselessness. Because with proteins in particular, structure and function are absolutely the same thing. Right. So if there is nowhere for enzymes to lock in, if there's nowhere for molecules to attach, for instance, in hemoglobin, and this is actually one of the cases in some of the anemias, specific bonding sites within hemoglobin for iron. And if any of those bonding sites are slightly out, so there's just one molecule in the wrong place, means that there's one bond that cannot be formed. Right, there's just not enough electrons there, or there's just not enough polar forces, then that iron doesn't attach. And then you get a whole bunch of excellent hemoglobin molecules running around your body that are just slightly damaged and they're not carrying any iron at all. Okay, and that's a bit of a problem. All right, so let's have a look at the model answer over there. Okay, oh, so sciencey, Kath. A protein or nucleic acid, now that's just showing off, just say protein, loses its three-dimensional structure, thank you, Steph, which results in loss of function. That's your chief thing. Loss of structure equals loss of function. Yep. Anything beyond that is a bonus. If you just said loss of structure equals loss of function, you probably get the marks that you need. Okay. However, the next bit is fairly important. So it loses its structure. And then the next question is to ask how. How could it have lost its structure? It doesn't just happen by itself. So what happens? So temperature. will denature proteins beautifully. It's what makes them tasty, actually. So we use temperature to denature proteins all the time. pH, as I said, acid, wonderful way of breaking chemical bonds. Salt concentration, if it's very, very, very high. Has anyone ever had, I don't know if there could be people here, has anyone ever had the Norwegian smoked fish or smoked eel or anything along those lines? It's truly disgusting. But basically it's packed in sea salt for 1 to 2 years or thereabouts. Essentially it's not fish anymore. It's like really, really salty oceany jelly because the proteins have been denatured. The faces that I can see, you're just going, I'm not going to Norway. But you might meet a really nice bloke from Norway, Rebecca. What are you going to do? What are you going to do? He's going to say, try my smoked eel. And you're going to say, we have to break up. Okay. However, as we said, because the loss of structure, we have a loss of function. If you want to go further and get all high distinction and fancy smancy, you could say that one of the big ways this happens is that like cells and like a lot of other things, the hydrophobic areas of those molecules are always in the middle, right? They're always protected but from any kind of moisture from the outside. And as soon as they become compromised or exposed, they get sticky and they clump together and they get destroyed. And of course, as soon as something is sticky, the enzymes aren't real happy about landing in a tar pit. So they won't bind to active sites and they won't do their thing either. Okay, so enzymes can't bind to substrate. So substrate meaning the proteins. So if you were to just concentrate on protein loses its 3D structure, which generally means a loss of function. How can that happen? Temperature, pH, strange Nordic men with salted fish. Don't write that. But you'd probably get a half mark, to be honest. And certain chemicals, but don't worry about that particular. Just go with temperature, pH, and salt concentration. And that means that hydrophobic regions are exposed and get sticky or precipitate, and then loss of enzymatic activity. That's huge. That's more than enough to put into an answer. Yeah. Okay. Is that reasonably okay, guys? Yep. Yeah. All right. Just think of it. You can do. This is one of those great things. You can study chemistry when you're cooking breakfast. Okay. Get yourself a googie, pop it in the pan. Notice how it's going all white and it's losing its clarity. This is denaturing proteins in the flesh in real time in your pan. Right? So do your chemistry study. Oh, I think I've just destroyed all those chemical bonds. Oh, I say the protein's actually not going to be working anymore. I might eat that. How delicious. Would you like a plate of denatured protein? Yes, I would. Lara.
I'm sorry to ask you a question again. When I was going through my module notes yesterday and stuff, I came across the objective, the concept of pH, its relationships to acid, bases, and salts.
Yep.
I got the acids and the bases part, but I couldn't wrap my head around. Maybe it was because when I was reading from the textbook, all of the jargon just overwhelmed me, but I couldn't get the whole salts situation. So
Okay, so a salt in general is a base.
Okay,
so you've got acids, and we talk about acids a lot, but we don't talk about bases very often, and so this is the opposite of basically the opposite of acids. If you go really, really heavy on the acid, really, really heavy on the base, either way, it messes up with all the bonds.
Okay.
Make sense?
Yep. Thank you so much.
That's all right. It is. I know. I've read the textbook many times, and sometimes even I'm, looking at it going, you could make that a little more complicated, but it'd be hard. It's like, what? Okay, let's go to the next question. Okay, describing now I didn't put this one on the slide. Go me. I actually got it right this time. Describing the covalent bond in a single water molecule. So we know straight off, we should go, right, water molecule. We all know that. That's a simple molecule, right? 2 hydrogens, 1 oxygen. We know that because we knew that from primary school. Yep. Now, we know it's a covalent bond. So we're talking about shared electrons. So if that was the only thing you came up with, that's still something, right? Still a good 2 marks there. If you tell me what the atoms are in the water molecule, and then you describe to me in basic terms, what does covalent mean? Sharing outer energy rings, sharing the electrons in an outer energy ring, yeah? So that's something, right? So that's literally describe, have a look at that. This is in your handout as well. You need to tell the reader what you see, and that's it. It's a verbal picture. So it's not a philosophical treatise on whether covalent or hydrogen bonds are stronger. It is literally what goes on between those 2 molecules. And there's not a lot, which is interesting because, quite frankly, water is one of the most confounding molecules of all time. It doesn't behave the way it should. We're still figuring it out. Science doesn't know everything. All right. Have a go, see what you can, and again, I'm going to say this is a 3-mark question. So we've literally just given you 2, really, said that there's 2 hydrogens and an oxygen, and you've got the covalent bonds, which is about sharing the outer energy ring between electrons. See if you can think of another one. And even if you couldn't, you still got 2 marks out of the 3, which is pretty damn good.
Catherine, can I ask a question?
Yes, of course you can.
So I'm going to go back and do bonds because they are totally confusing me.
Yes.
But I did answer this question, and this is going to sound really stupid. The answer doesn't make any sense to me, but I want to know if this answer makes sense to you so I know if I'm actually on the right track to go back and look at what I was looking at.
Sure, sure.
So if I wrote, this is when there is no electrons physically exchanged and each bond is a shared pair of electrons, does that even make sense?
It does.
Okay.
It makes perfect sense to me, yeah.
Okay.
It's shared. That's right. That's exactly right. You're sharing electrons on the outer energy levels. That's exactly right. Yep. Okay. If it doesn't make sense to you, it's actually a perfect answer, Beck.
It doesn't make sense to me. I wrote it and I just read it and I'm like, why did I write that?
This is
like, it doesn't make sense yet. So I'm going to go back.
When I say that you know more than you think you do, obviously your conscious mind doesn't understand it, but your subconscious is getting it pretty good.
It understood it on Sunday, so
right, exactly. So, and exactly what you said. It's about revisiting and just cementing and concreting that knowledge. Then, yeah, yeah. But no, you're absolutely right. That's really good. If you could write exactly that, the atoms, mention what the covalent bond is. You've got it. That's the answer. Okay. So let's go. Where's my thingy? I've lost my button. She says. That could be taken so many ways. All right. Okay. We all recognize this. This is our little water molecule. So it's exactly what we said. Now, we're talking about a describe question. So when you get a describe question, describe your butt off. Like, just go nuts with this. All right. So basically, you've got to keep demonstrating your knowledge. Right. So we know that electrons are shared, as Beck just said, between the oxygen atom and the 2 hydrogen atoms. And then go ahead and tell me that you know stuff about those atoms. Okay? Hydrogen has 1, oxygen has 6. All right? So, and don't forget, these are open book tests. You can look this up. That's fine. Okay? And we want a stable configuration. So this is really, when you're talking about any bonds at all, particularly covalent, you can use the word stable configuration, because every atom, every molecule wants to have this most stable state it possibly can. Okay, so that's why the electrons are shared. I am not stable. I would like to feel more stable. They've got personalities and feelings now, apparently. But that's why the electrons are actually shared. It's stronger for both molecules. Hydrogen's only got 1, so it's highly unstable, where you've got your oxygen with 6, which sounds stable, but it's not particularly, and they're sharing it to become more stable. Okay,
Sorry, I'm really confused because we're talking about sharing, but the question, I'm reading it as it isn't being shared. Yeah, just really confused with the question, to be honest.
No, that's okay. That's okay. So just look, let's go back to the question. All right. So what are we being asked to talk about?
Covalent bonds.
Yep. Yep. So now I'm trying to get to the bottom of now why is your brain going then that the electrons aren't shared? They're not exchanged. Is that where we're getting confused? They are shared.
Yeah.
Yeah.
I might just have to go over the reading again.
Yeah, there's the ionic bonds and the covalent bonds are I think that's probably where you're getting yourself into a pickle, is the difference between the ionic and the covalent. Yep. So again, don't even go back into the readings, to be honest, like just be Googling that stuff. Find the simplest explanation first, then take the simple and go back to the more complex information. Because basically what that's saying to me, Chloe, is that the way that it's been explained to you in lectures and notes is super unclear for your particular way of understanding. And that will be the case, guys, with a lot of, I think I said this last week, a lot of information. It'll depend who's explaining it and how, and which particular words they're using at the time as to whether or not you get it. And if you don't, you've got to go out and find someone that puts the words together the way that you get it. And it'll be different for everybody. Really, really different. Yeah, Laura.
So I'm also finding this very overwhelming.
Okay.
And so Chloe, I'm in your boat in the sense that I completely understand. My question is, because this might help Chloe, if I'm correct, because it's the only way it helped me understand it.
Yep.
Is it similar to kind of they become a conjoined twin, like they share one I don't know, I'll have to go back to my summary of it. Yeah, they're joined together now at the hip. Is that a way of thinking about it?
Yes.
Yeah, okay.
Yes,
they
it is.
Electrons, making them attached at the valence shell.
That's right. That's right.
All right, thank you. Sorry, guys.
Laura, that by the way, conjoined twins was an excellent metaphor. That's a really good way to think about it. Really, really good. Thank you. Okay. So that is literally, pardon me, I've got a real frog now. So yeah, that is a really good way of thinking about the covalent bond, actually, is exactly that, conjoined twins. Yep. And then obviously that final paragraph that I've got up there for you, it's really not necessary. You can memorize that if it makes you happy, but please don't feel that you need to. Honestly, I was going to cover it with my hand thinking that you're alive people, but you can't see me doing that. So that's just the first three would be actually really fine for this answer. Okay, that they're shared between the oxygen and the hydrogens. Tell me how many they've got, 1 versus 6, and tell me that it's a stable configuration at the end of the day. That will be heaps. Is that okay with everybody? Further than that, it gets into chemistry that you need to know not of. Yep. So by all means, I'm not saying don't go study more chemistry if it makes you happy, but the level that you need to understand at this particular point and spit out again is literally just, there are different kinds of bonds, name them. Let's talk a little tiny bit about the covalents in particular, because they're the most common in the human body, and what can muck it up. Yep, acid, pH, temperature, and that's basically what's going on, and huge mechanical force as well. But you can split an atom, as you all know, because I'm sure you've all heard of Hiroshima and Nagasaki. Okay, all righty. So please don't, conjoined twins, cohabiting as well. There's a lot of co's that could go there, the metaphors that could happen. Conjoined, cohabit, co-occupy. Go with that as your understanding. And Lara, I'm going to smack you. Never apologize, because you were so right and you said exactly the right thing, and it was really helpful. And Chloe, did that make more sense when Lara said that?
Yeah, actually really helped me. unscramble my brain a bit. So
you like
cool.
you
No,
really
it's my
it's
social
great.
anxiety. I feel bad for taking over the class. I don't want to
You're not.
bombard everyone. Everyone
You're
has a
not.
right to say something, so I don't want to.
No, please, guys, if you have in any of these tutorials, if you have an insight or if you have a way of understanding it that is particularly yours, and actually, honestly, even if it sounds particularly weird, right, where you go, I thought of this like this, and it's got, I don't know, it's some metaphor about toffee and something, it will probably help somebody. Probably. If you share it, make sure that my son's giving me love heart symbols. I don't know why. So share it, because, you know, and also remembering all of us that are teaching, we've been in science world for a long time, and you do start to think in that way. So when someone comes up with a new metaphor that I haven't used before, it's incredibly helpful. It's really, really good. So speak up. It's about co-learning as well. Yeah, good. I'm so happy with that, Lara. I'm chuffed as hell. You can join twins. It's brilliant. Good. All righty. Now, moving on to our very, very last thing. So we're talking about our bonds, etc. And remember, it's not a chemistry exam. It is not anything massively complicated. You don't need to go crazy, but I do want you to take a few minutes to Google some of these answers, to ask ChatGPT or whatever it is that you want to do. But basically, a simple explanation. Let's call it a 3-marker. Well, how about we don't go to the answer? We call it a 3-marker. Why carbon is, well, why do we have carbon-based life forms? Why is it such a useful atom in forming biological molecules? And I guarantee you, nothing on that particular pictorial slide is going to be there as a hint at all. Okay, you don't need to know that its atomic weight is 12 point. Doesn't matter. Its electron stability, it might be something to look at. No?
I might be wrong in saying this, but is it because it's an organic compound?
Yep.
Is that right?
That's one of them.
So it has 4 electrons and
yep.
It's stable?
Yes, it's extreme, because have a look at the distribution of the electrons as well.
Okay.
So there's 2 on the P and 2, we used to call it the ring. I still do it sometimes because it's easier for me to remember the rings than it is to remember that they're floating in relative space. But yeah, 2 on the P area and 2 on the S area. It's incredibly stable. There's no imbalance between those areas.
But I'm on the right track.
You are very much on the right track. Other than that, who cares that it's period 2? Who just cares? Well, it's nice to know that it was discovered in Sumer, Egypt, but it's not going to help your answer. Yeah, Steph.
Does the 4 electrons in the valence shell makes it readily available to gain more electrons? Like it's a flexible element?
Yep. It is very flexible. That's another excellent observation. Good.
Yeah, and it contains other functional groups I had, like hydroxyl, methyl, carboxyl,
yep,
amino and phosphate.
Yep. If you say that, I'm going to drop my pen in shock and just go, sorry, excuse me. This is like 7th year chemistry. But yeah, you're right. It does. It's there's all that stuff going on as well, but it's probably way too complicated for this particular explanation.
What about,
but good.
Yeah. Like it's the backbone of all organic molecules?
It is. Put that in, but then maybe that's a good way to start. It is the backbone of all organic molecules because stable electron shells, extremely inert element. Yeah. Jamie, sorry, you want to jump in?
Yeah, sorry. Did we miss a question about the electrolytes? Question 4 on the tutorial street. There's one that's mentioning electrolytes.
Did I miss one?
I think
so.
Question 4. Define electrolyte.
Okay, we will go back. We'll stick with carbon for a second and then we'll go back to electrolytes. I do apologize, guys. That's terrible. I'll fix it. Okay, so all of those answers so far, exactly right. So if you can just remember 1, 2, 3, 4. Like, I mean, I know that's just a list and it didn't ask for a list, but it's a good starting point. It's versatile, right? It is incredibly stable. It's able to be quite diverse, which is kind of the same as versatility, to be honest. So if you put versatility and diverse in the same sentence, that would be fine. And the big one is that carbon-based molecules, this is one never to forget about carbon and why we talk about alien life forms having a different base instead of a carbon base, is that carbon-based molecules particularly are compatible with water. And water is our big solvent in organic systems. Okay, so if you're not compatible with water, then that's when we're starting to talk about, you know, other different alien life forms that might be not carbon based, but on a water planet and with our particular system, carbon is the most compatible element with water. And that's really important when it comes to anything that involves long carbon chains, which, like for instance, the carbohydrate, so-called carbon hydrate, water. Yeah, it's a good one to remember. But lipids and proteins have very similar structures. So their cellular structure and function is based entirely on the fact that carbon and water interact beautifully and form solvents and bonds. Okay. And because of that stable electron structure and because of the its water compatibility, it's pretty infinite in how many structures it can actually create. Size, shape, branches, all sorts of amazing stuff that goes on with carbon-based molecules. Okay, I won't ask you, I would ask a chemistry bunch what would happen with what molecules can you make without carbon, but I don't think I'll ask you that. Let's just ignore that. You can research that for fun because you're a nerd. But it is fun. Okay, you might want to look into alien life or something. It can be fun. And you never know, you know, if Elon Musk is right, you may end up nursing something that isn't a carbon-based life form, and you're going to have to come up with solutions, and it'll be like in a movie, and you know, but we can't give them this, we can't possibly give them that IV because they're not a carbon-based life form. Anyway, so is that, like I said, that the answer I've given you there is too big, but if you write it down or screenshot it or whatever, turn it into your own words, simplify it a little bit, then you've got a lovely answer to why carbon-based life forms. Okay. Sorry, stick with me while I figure out what I'm doing. Characteristics of water, yes. Oh, okay, is this in your notes? Can you see this? I've obviously just had a slight brain problem when I put this together. Let's try it anyway, because it's a really good revision. Okay, so let's go through and find out what we would highlight in pink, what we would highlight in yellow, and what we would highlight in blue. This is really easy, okay? So we're trying, pink would be water as a solvent, yellow is water as a lubricant, and blue is water's ability to absorb and release heat. So sentence number 1, cells receive the chemicals they need to function. Is that a function of it being a solvent, a lubricant, or heat? Is it pink, yellow, solvent? Yep, good. The heart beats freely without encountering friction.
Lubricant.
Lubricant. Joints operate smoothly.
Lubricant.
Lubricant. Stable temperature. I think the wording gives it away.
Release heat.
Yes. Chemical compounds broken down into smaller components that cells can use.
Solvent.
Solvent. And expansion and stuff of lungs freely.
Lubricant.
Lubricant. Smashed it. Good. Good, guys. Excellent. All right. That was a nice. Oh, I've missed one. Sorry, your face boxes were over it. And sweat cools the body.
Releases heat.
Thank you. It's like a choir. It's lovely. Good. All right. I'm just going to keep going just in case I have got. No, I haven't. Okay. That's okay. What we might do is stop looking at my slide that I didn't put the electrolyte question into, and someone can read me that question and we will answer it together as a group.
Abnormal levels of electrolytes can be a sign of serious health problems, including kidney disease, high blood pressure, and life-threatening irregularity in heart rhythm. Define electrolyte.
Okay, so define an electrolyte. Does anyone want to give that a go? I'm not going to do it for you. I'm going to try and get you to get to the answer, hopefully. We know them. We know them. You can be brave. You drink them. I'm sure that one or two of you have had a sports drink in your life. What is in a sports drink? What is an electrolyte?
Ions.
I can read what the textbook said.
Yes, please.
I couldn't remember reading about electrolytes. I must have missed this in my notes because it wasn't a learning outcome.
Yep, that's right.
So electrolytes are substances that ionize in water, acids, bases, or salts, and form solutions capable of conducting electricity.
Right. Exactly. So just take that. Basically everything in your blood, acids, bases, and salts, they're all electrolytes. That's why all, sports drinks taste salty, to me anyway. Yeah, Rebecca?
I have like a big Y circled in my notebook because it must have led into something about free radicals, and I got really confused.
Okay.
Yeah.
It is connected, but only sort of vaguely. I'm trying to draw an imbalance of those ions can increase the activity of free radicals, because you're basically changing the basic nature of the solution. When I say basic, I didn't mean acidic basic. If you change the amount of electrolytes or dissolved substances in people's blood, what do you think happens? Like if I have to, well, guys, you know what happens. If I have too much salt in my blood, what's going on there? What's going to happen? Yeah, absolutely. What happens with cells, I think this is actually next week, so I probably won't be able to answer it, but what do you think would happen if I put a human cell, a red blood cell, into really, really salty water? If you think about, the fact that a cell's got a very, very thin wall, and your blood is salty, but I'm talking about what about super, super salty, right? Like Norwegian fish kind of salty. Yeah, it actually, so water moves, and this is a preview for next week, but water moves from an area of low concentration from an area of high concentration to an area of low concentration. So when you get, if you've got the outside of the cell being saltier than the inside, water wants to go and dilute. Even if there's not enough of it to do it, that's its job. That's its mission on this world. So all the water flows out of the cell and into that salty solution to try and get it balanced. Right? So the electrolytes in your body and in your blood, the point of them, when they get gradient, exactly, thank you, Hannah, when they get too much or too little, it affects the movement of water hugely. Right? So keep remembering, water is going to try and move. It's going to try and dilute wherever it's going. Okay, what it wants is even. It wants even ions inside and outside the cell, and it wants even water concentration inside and outside of the cell. Yeah, and so if there's too much in one area, you will either get, so for instance, a cell that doesn't have enough electrolytes or solutes in it, the water will rush in and the cell will burst. Right, which is why we can't give plain water to people in IV drips. Right, literally we would explode their cells. Yep. Sorry. Yep. Steph.
Hey,
Hey.
yeah, is that osmosis that we're talking about there?
Which is indeed. Yep, absolutely. No worries, Samantha. Thank you. See you next week. Yes, exactly. And we are going to go into that a little bit more, but this electrolyte question is very simple. Tonicity, thank you. People are reading ahead. I'm loving to see that. Just for this week, it's just a matter of knowing though that those electrolytes and those solutions, those elements within a solution are going to affect the cells that we're talking about. And we don't need to talk about this as theoretical chemistry. Literally just think of it in terms of how it's going to affect cells. Okay, so we don't want basically too much is too much, too little is too little. Yep. And you'll see this, and it always has massive health effects one way or the other. Too little iron, what do we call that?
Anemic.
Anemia, yeah. What? Oh, here you go. Too little B12, dissolved B12.
Aplastic anemia? Is that
Nearly pernicious anemia, but yeah, exactly, another anemia. So too little of anything is going to have health effects. So maybe a good thing to do this week is to go through and say, let's have a look at what the ideal distribution, and I'm pretty sure this is in your lecture notes and your textbook, what is the ideal distribution of the different elements in blood, and then what happens if we wreck any of those elements. Does that make sense? Or if we have too much or too little of anything given. All right, we have gone 6 minutes over, which is very bad of me and people who are, if we have a practice test before Sunday, I would say yes, Jane, because they're onto it. But that you'll need to put that question directly to Tabin or to Natalia, because I don't actually put the tests together. So I can't even answer it for you, I'm afraid. But whoever's on it will be on it, and it'll be up as soon as humanly possible. All right, no worries, guys. Thank you all so much. Is there 10 or 20 questions in the test?
20.
20 as far as I know.
Yeah.
Yeah.
Sorry, that was me. And I read today, the post that was put up said 10 questions, but then the writing thing, no, it said 20, but then the page thing where it says it's worth 15% only had 10 questions listed.
What's in your subject? What's in your subject outline? Because that is your clear and legal document with the university, and they can't ask you to do anything that isn't in there. So whatever's in
10 questions.
Well, then the answer is 10.
Okay.
Yep.
Thank you.
I thought it was 22. I think you're right. I think this one's 10 and the next two are 20. I think because they're higher weighting.
I swear it was 20.
You'd swear it was 20. Look at your subject outline, guys. The answer is there. Sorry?
I think it's 20 as well. Because
Right.
I did a practice test and I had 20 questions.
Right. Look, it'll be in the subject outline. I promise you. Whatever's there is there. Is chemistry involved? Whoa. Sorry, chat just went crazy. Give me a second. Question before we go.
20 questions taken from contact in modules 1 and 2. The test is structured as a case study and questions relate to, oh, hold up, I'm reading the wrong subject.
I love it. The wrong subject. Yeah.
The subject outline doesn't say how many questions.
Yeah, it doesn't say it.
It says mini test.
Modules 1 and 2, from what I've
Yeah.
seen.
On the assessment 1 tab, it says that you are required to complete an online quiz of 10 randomly allocated questions, and you have 40 minutes to complete this quiz.
That sounds right to me.
It says there's 5 questions worth half a mark each, and then multiple choice, and then there's 5 short answers. Yeah.
That sounds like it, Taylor. Yep.
That's what I meant.
Yeah.
But then the things posted earlier said 20 questions. That's why I was confused.
I will take this back and make sure that Natalia is aware of it, because it sounds to me like the materials you're given aren't agreeing with each other, which is not a good thing at all. So I'll take that back tomorrow and make sure that we look at that very carefully and make sure that an announcement goes out that actually tells you exactly what's going on. Yeah.
And just one final thing, whereabouts is when is the mini test going to come on? Because if it starts Wednesday and that's the day I've got to do it, given my life, is it coming on Tuesday or something? Or
I think it's Wednesday to Friday we have to do it.
Yeah, there's usually around about a 40-hour window.
No, I mean the mini test. It says, oh, I thought when it said online mini test, it said like that was going to be the practice test, because some of my subjects have practice tests before the mini test, and I just got confused there. So there's no practice test available. It's just the link to the mini test. Is that correct?
As far as I know, but again, I'm not doing the assessments, so I can't really. Look at your subject outline. It's there. But yes, the mini tests are open for a long period of time. The biggest important thing about them, though, is that you've got your 40 minutes or whatever it is to do it. But that's all you've got.
Yeah.
Yeah, you can't come back in and get back out.
Sorry, I asked in the discussion board yesterday if there was a practice test, and a few of the others commented saying that they thought there was as well. But is it Tabin?
Yeah.
Yeah, replied saying that there is no practice one for this.
Good. Well, that's your answer. You shouldn't need a practice test at all. That's essentially what your tutorials are. That's why we're going through these questions and making sure that you know the answers to these questions, because remember when I said last week, they're very closely aligned.
Catherine.
Yeah.
Are you able to email me the week 1 worksheet?
Yes, absolutely. Yep, I can certainly do that. No worries. And look, I think I've got a funny feeling, guys, that the worksheets will actually end up going on to I2 in the next couple of weeks. But absolutely, in the meantime, Tori, I'll make sure that you're okay. How about, here we go, guys. Tell you what, there's lots of people that would like that. So can I please put my email address into the chat box? And if you would like me to email you a copy, could you please send me off a quick email?
Is there any chance you could just send to everyone one? That way you're not doing them individually. It might, because it wouldn't make a difference to the amount of emails that we get anyways.
Could you just link it in the chat now, and we can download, and anyone who wants it could download it?
Yeah, from last week.
Yeah.
Yep, I can.
I'm sorry. Just I asked this question myself last week because I missed the tutorial. On the I2 site, on the left-hand side under learning content, there's actually a folder that says tutorials, and the worksheet is in that.
It's in there already. Okay.
Yeah.
Good. They told me they were going to do that, but I wasn't sure that they had done it yet. So that's good to know. So they're there. And there's also tutorial 1. I just popped that into the chat box there as well. Right. And also my email address in case you need it for any particular reason. Cool. All right. Now we definitely have to run away or we'll get in lots of trouble. 6:12. Okay. No worries. All good, guys. Have a good evening. I will see you next week for not chemistry. And it'll be a little bit easier, I think. All right. Have a good one, everybody.
Thanks, Catherine.
No worries. See you soon.